the stream. Make sure it's coming up. And see if the audio is coming in. Okay, I can hear myself, so that's good. Good news. I think we will wait for a minute while people wander in as I prepare my mate and ponder what we're going to work on today. Let's see here. Some settings here. All right, looking things up here. I'm new to this streaming thing, so everything takes me longer than most people who's been doing this for a while. Streamer mode, cogwheel. Okay. That. Streamer mode. There we go. Okay. Hey, Robot Bison. Welcome to the stream. What are you doing here? It has been forever. My goodness. Let's see. Are you still in Central Time Zone? Oh, nice. So you're East Coast like me. So you're hard at work already, huh? You just need some noise in the background. Oh wow, last week. So everything's still in boxes. What's it been? Almost what, maybe 10 years since we played League of Legends? LAN party? Oh, it's not even all there. Yikes. Seattle. Oh, awesome. Good to hear from you again. Oh yeah. You did come to a couple D&Ds. We also had the board game nights. You came to several of those. How's the family doing? Seven and 5. Wow. Cool. Congratulations. Well, the good news after about 2, it doesn't matter how many more you add in, right? It just you go from man-to-man defense to zone defense. All right. Well, Robot Bison, since I think you're the only one in here, I decided to make a game with no game engine, and it's a fairly simple one. It's an homage to an old game I played when I was young, and it's a word deduction game. And right now it's all programmer art or no art, but 3 different play modes. You try to deduce a word, and in marathon mode, it's you go until you mess up. So the number of words guessed is all that matters. In sprint, you have to get 6 words right, and then it's just time from the time you start typing. And in golf, you try to get 9 words in a row, and it's the shortest number, the least number of guesses is what gets you on the board. So we'll go to sprint mode. We're not going to play through a full game. So we're on level 1 of 6 for sprint. The timer starts when I start typing. And there's a bunch of deduction tricks. So we know that these 15 letters are unique, and all 5 letters in these words, all 5 letters in the result is in these 15 letters. So we can remove every letter that's not in those 15. And there's a shortcut for that. So that's always handy. We guess some words. And I do have reasons why I'm using these words, but you just try to deduce your way through. This is interesting. Oh, well, okay. I have a shortcut for selecting all the open letters in a word. You just double click it. And if you want to make the gray letters red, you right click twice, so that all goes away. O and U are out. L and C, oops, are out. There we go. T is out. And N is in. S is out. And H is out. Which means I made a mistake somewhere. 2, 1, 2. Yep, toads. I messed up somewhere. So we can just clear the deductions. Try that again. See if I can do it without making too many mistakes. Those are all gone. These are all gone. Nope. Yep. This is in. There we go. That's in. T is out. U is out. Okay. So this might be like shade. Uh-oh. Might be Hades. Oh, Hades isn't in the list. Oh. Fallout terminal puzzle. You know, I've never played Fallout actually. Probably a character flaw. Hades. I thought that was a good one. Shed. There we go. We can try shed. Oh, interesting. Got all the letters. Just need to know what order they go in. Maybe it's an ED at the end. Hazed. Sometimes it throws words at me I don't know, and other times I find out the answer. I'm like, I didn't know that was a word. Sometimes I get weird biology words. Anyway. So that's the game, and when I type in the words, you can hear the number of ticks based on the number of matched letters. We type shade again. There's 5 ticks for 5 letters. Our goal today is to stop using generated waveforms like sine wave, square wave, and actually embed audio. So whatever this word is, oh, it's heads. I should have known that. But I don't have to be good at the game to program it. So that's what we're going to work on today. So I have an audio pack that I bought years and years ago, which, let's see, what's the best way to, let me think. Where's Yes, I can. Well, what the heck? We're just gonna share the whole screen for a moment. We'll come over here. So I have some files that I've got that I purchased ages and ages ago. We're gonna pick one or two, and then we're gonna dismantle the waveform based on the specs for the wave file and embed just the binary data in the executable. So part of the mission of this stream is I want to not use an engine. I want to keep my dependencies to a minimum, and I want everything to run straight out of the executable with no dependencies, no extra files, nothing. And keep it as small as possible. Not as small as possible, but smaller than the bloat of using an engine, right? Like I've used Unity before, and even just a basic empty scene that doesn't do anything is hundreds of megabytes in assets and running executable. It's ridiculous. So I'm trying to just keep it as minimal as possible without killing myself. So you can see the dependencies I've used. I'm using Glue, GLFW, I'm using GLM, which will go away in the next game I make, and free type for the font rendering, which may go away on the next one, the next game I make, because this one is ridiculous. It pulls in so much junk. Port audio was pretty straightforward, so I'll actually probably keep using that. It's been a reasonable experience. So that's the plan. That's the goal, is to get through a game and then build up from there. So we need to pick a sound for how many match. That's not bad. 3? If you have strong opinions, let me know. Oh, somebody's got a kick drum in here. Okay. So sound design is not my forte, but I think wow. Interesting. Chimes. So maybe we can use something like chime bell confirm when you deduce the word correctly. Oh, yeah, any of these chimes would probably work. Oh, that's so pretty. I need like a. Oh. Oh, and you probably can't hear it. I don't think I'm sharing audio off of this window, which is very clever of me. Oh, you did hear it? Oh. Interesting. I thought I have that muted. Fix digi. Be nice if there's like a error. There we go. Yeah, that's not terrible. Be able to tell people. Whoa. Etc. Camera, door, drum. Does not sound like an error buzz to me. To be able to tell people when they've made an error or when they lose. Musical? Oh, there we go. Bongos, marimbas. Alert. Well, pads. Whoa. These are a little bit long. It's not bad. Whoa. Oh, a zap. That might be a good error sound. You lose. That's not bad. Okay. Well, let's start with it. Click 3. Click 3. Okay, well, I'll go find it somewhere else. So let's go back to Emacs. Mode. Let's turn off desktop audio. There. What the? There. I think I muted the right channel now. That's always awkward. Okay. So here in the assets, I've embedded like my shader code. It's all, I type it in here, list of shaders that I use. That way I can have shaders in here that aren't embedded while I'm experimenting. And then this list is what's eventually processed into my executable. Same with fonts. Here's a couple of fonts. These will probably be replaced as we go. List of fonts that I want actually embedded from this directory. Images. This will grow. Oh, why Windows? Why do you suck so bad? As we actually add some art. So first we're going to make a new folder. We're going to call it sounds. And we'll put click 3 in there. Paste. And then this is probably, yeah, sure, like fonts. We'll copy that as a starter. Put that into sounds. Okay. All right. So in our assets, the sounds, fonts.text. Rename the file in the buffer to sounds.text. And where this is run from is up and over a directory or two because of the way we build it. So click o3.wave. o3.wave. Let's see here. And in our library, we'll call it click.wave. Okay. That way, go into assets, sounds. Let's see here. PNG stuff is probably the most useful place to start. What did I call it? Tools. It's in tools. Embed PNGs. Okay. Embed WAVs. Okay. I don't don't need load PNG. We're not doing compression on images in this one. I have a logger, it's fine. So we're reading out the file, and it will be sounds.txt. This is not an image warehouse, but a sound warehouse. There's already a lot of helper code I've written. And then okay. Here's the part we don't want. Except eventually I'll need to know a few things. We need to write bin. That's a functional lead. Data. So the way we load the file is going to be different. Which we can steal from a different example. Embed shaders. It's going to look a lot like this. So read the file. Data size, right? Text. Okay, well, we're not writing text. That's going to be different. Size of everything. Okay. So we're going to read a file and do things with it. So that's the question. Everything's going in chat. Okay, that's what's going on. Cool. All right, so right now I'm using, let's see, probably trying to decide which reference is best. Probably this file format specification to parse out the wave file. So in here, we read the file. And here, where write text would normally go is where we're going. So we have the data. And that data is going to address 0. We're going to type punit. To an integer pointer. Dereference that. Do I want to do it that way? It's fine. If data 0 is equal to R and data 1 equals I. Do I want to cheat? We could cheat. There are a lot of different ways we can go about this. Anytime you start working with binary files, we'll just do the readable one first. It's 2 equals F. And 3 is F. And that is not true. Invalid wave file. Missing magic number. Now we can't accidentally feed it a PNG. Next thing in spec is a chunk size. Which we will just write out. That's 4 bytes. So let me think. We're going to assume success unless we run into an error. Okay. So the next thing is chunk size. The sum number, which is data at 4. As a 4-byte integer. And then we're looking for format code, which will be chunk size 4 plus it. And the wave ID is 4 bytes as well. And then the number of wave chunks containing format information and sample data. Eight, 9, and 11. Yeah, 12. Number of chunks. That is chunks in. Okay, so it doesn't tell me the number of chunks up front. I just have to find each chunk as I go. Chunks. So the first chunk should be format. But let's have to get started. Big file. Build target equals embed sounds. I should figure out what to do with that. Embed waves. Right source. What do I do to right source? I stole it out of getting linked to. Okay. Build. Includes it's not linking it. Oh, it's built all objects is defined. It's not linking properly. This should be easy. Why is this hard? There's objects, there's build that requires a target. And the objects. I should load those objects. What is this doing here? And webs and the objects, right? CPP and the objects. Missing a step. Huh. Okay. Go to tools, bin, embed webs. Just see what we get. Chunk size. Let's make it very clear what's working and what's not working. We have riff, we have web, we have a chunk size. Next thing we would expect is a chunk starting with format, which is 4 bytes and space. We'll come back later and turn these into integers, make the comparisons easier and faster. We'll get there. So 12 and 13, 14, 15. We're looking for format. We also have full control over every file we use. I won't actually be providing it with invalid files, so a lot of this error checking is going to go away eventually. Hopefully the sound's back. Then after format, we would expect a chunk size. At 16. Huh. Well, I guess it's fine. Run it again. Okay, we have our format, we have our chunk size of 16, and it is 16 bytes in the chunk. Okay. So we're gonna get a format tag, 2 bytes next. Format code. The contents of a C standard int in here. So I can actually have control over my integer sizes of an int 16 t pointer at data plus 16, so 20. Code will be 2 bytes there. The format codes are let's see, one is PCM 367, I think most common ones. 1367. PCM is for pulse code modulation. It basically means that you're getting an integer value in some range. Usually it's like 16-bit PCM or 32-bit PCM. Very common. Integers are easy to work with in a lot of cases for speed. This one will be IEEE float, so those will always be 32 bits per sample. A law encoded, and then U law encoded, which I have used mu law encoding in PCM and IEEE. I've never used A law, or maybe it's alpha law. I don't know about that one, but U law is fine. Okay, so that should be that. Otherwise, default. I'm not going to work on handling most of these. Maybe PCM IEEE. I don't know if I want to handle mu law at this point. Known format. Be format code. And there we go. We should see what format this is. Okay. PCM. So this is PCM. All right, next field. Number of interleaved channels as 2 bytes. That should be 2 in this case. So we'll just get that. Num channels. 2 bytes advance from there. Okay. Sample rate is next. I'm hoping it's the same as what my hardware default sets, because I don't want to fiddle around with the port audio. I like to just take the default that a hardware specifies. But you never know. Sample rate in hertz. Data rate, which should be computed from the above. Data rate is bytes per second, 4 bytes. So 26. We're making it 32. And that will be in bytes per second, not bits. Data rate. Block size. Is another 2 bytes. 26 plus 4 is 30. Size in bytes. Bits per sample, that actually is useful. Because each sample has the number of channels and the sample rate and the, so it ends up being, bits per sample is a 2 byte value at 32. Bits per sample. Size of the extension, 0 or 22. Interesting. I mean, we'll print it out just so we can see it, but it's a 2 byte value. If you have any questions, comments, concerns, let me know. I'm always happy to chit chat. I don't always remember to check the chat, so just let me know. Size of extension. There we go. Valid bits per sample. See, some of this stuff seems a little silly to me. So 32 plus 2, 4. This one 2 bytes, 36. Valid bits per sample. Speaker position mask or channel mask. I guess the valid bits per sample kind of makes sense with this. Then I mean, G sample could be like a 7-bit value. So let's see, channel mask, and that's 4 bytes. 36 plus 2 is 38 bytes in. And we're going to do this one in 8x. Okay, sub format. So yeah, I don't think there's any information that's useful in these sub format, but we'll grab it anyways just to look at it. Format, that's one to grab. It's, oh, sub format is 16 bytes. You know, I don't think I care about that. We'll skip it. So we'll add 16 bytes on here. So 38 plus 4 is 42. 42 plus 16 bytes to get over that area is 58. Okay, so the next one will be 58. At that point, we expect another chunk, and it's going to be a different kind of chunk. We have a fact chunk for compressed formats. If they're compressed. A data chunk, so if this is PCM, which it is, it's not compressed. So we probably won't have a fact chunk. So let's see here. Let me do this. Let's break this up a little bit. Read chunk. That will actually call read format chunk. Read a fact chunk and a data chunk. And these will need the data and the data size. Because eventually we will be doing all of these. And each of these will have to report back how many bytes it read. Okay. So read chunk is going to start basically here. When we read a chunk, if we get format, we get a chunk size. Then this will read format chunk, given our data size, the offset plus of red. Yeah, just a moment. Come on, mute. My thing. Okay, I'm back. and sine for package. Okay. And we'll look for these other ones, but we just start doing this better now since we're already starting to break things up. We can. Let's go look up ASCII. ASCII table. FMT space. So F in hex is 66. M is hex 6D. T is hex 74. And the space is 32, which is hex 20. Data. What's the offset? Treat it as an integer. Content of that. There we go. Format chunk and a chunk size. There we go. Or are all chunks are forward letters? Data, fact, format with a space. Yes, they are 4. They're always 4. All right, chunk ID is equal to format. Log it. We get our chunk size. Okay, chunk size is 4 bytes. Yep. There we go. If chunk ID equals. All right, so the next one is a fact chunk. So F will be 66 for 94. A is hex 61. C is hex 63. T is hex 74. so that's fact, and then we'll need data. ASD is 64, A, T, 74. Just did this, yep. 74, and then another 61 for A data. Read the data chunk, okay. And then up here, we were already parsing out a lot of the format chunk. Okay. So 12 comes in here, and we move forward 8 bytes, which puts us at 20, so that is correct. Offset. That is equals to so let's see. 2, 4, 2.
Daddy,
Shh, that's
have some V8.
I only have the spicy stuff.
No.
It's plus 4. And then we're gonna skip over those last 16 bytes. Then we're just gonna find all instances of data plus and put offset in there. If I can type. There. Okay, that should read the fact chunk just fine.
Okay.
I'm just gonna stub this in real quick. Fact chunk. And data chunk. And then we'll fake it on this side. Plus equals the chunk size. Should work. For these two. There we go. So we should be able to read chunks until the size is bigger. So we've passed the end of the file. So we're going to parse read chunk. Equals 12. Well, offset is less than data size. Keep reading. Indent everything inside of a chunk just so that it looks different. Space here. There we go. Okay, I'm actually try this and see what it does. If my children's screaming is too loud, let me know and I'll shut a window or something. At least it's happy screams this time. Oh no, we've got errors. Value not ignored as it should be. Um, who's taking that? We always pass them. Void value not ignored as it ought to be. Read chunk. Hmm. Void value. What void value? Data. Set is 12. It's not void. It's an integer. I didn't update it up here. There we go. There we go. Okay. Now we see what we get. Made it as far as riff chunk size. And wave. So one question then is, what have I done wrong? Possibility one, data size is not what I would expect. Starting at 12 when we read a chunk. Maybe Maybe we just need to look at this real quick. 08 hex. Done something wrong. Maybe I have an endingness problem here with these magic numbers. So we'll take a look. Data rate. Now what we get? Yep. Okay. So the first chunk is indeed backwards. So it was an endiness problem. All right. So we just same problem with these guys. 74, 63, 61, 76. It'll be 61, 74, 61, 64. If anybody has questions about endianness, let me know. Just means the order the bytes are represented in. We did get a format, and it's 16 bytes. PCM 2 channels, the sample rate is negative, so that's awkward. Does the spec specify they're signed or unsigned? Sample rate just says length. It's delightful. Okay, data rate is also negative. Block size 2 bytes, bits per sample. Size of extension should be 0 or 22, so maybe I have a mistake somewhere in read stuff. 16 bits, 16, 4, 16, 2, 16, 2, 16, 2. Oh, maybe just make them all unsigned. actually going to read after that first chunk for now. We'll just break out. Okay. 2 channels. That sample rate looks correct and it matches my hardware. Very nice. Data rate still makes no sense. Oh, well. Just leave it as an unsigned. Block size, fine. Bits per sample, fine. Size of extension still off. Bits per sample. That doesn't make any sense to me. Getting close, we just need to size of extension. So I don't think I will have any fact chunks. But I should have a data chunk, so CB size. Number of valid bits. Explain to me what that means. Let me switch over to different reference. All right, we're also going to look at this reference, I guess. Yeah, thanks for coming, Robot Bison. Appreciate you stopping by. I'm not always on, but feel free to drop in again. Talk to you later. Hold on, going on mute. File size, wave, format, chunk, length of data format as listed in 16. Type of format 1, number of channels 2 byte integer. Sample rate. Okay, so
Daddy.
what? Okay. So if I'm looking at this correctly, then the bits per sample should equal this number. So we will go ahead and compute that and say sample rate times bits per sample times channels divided by 8. Just to see if we get the expected thing. Size of extension back to the docs. Bits per sample. It'd be 17,6400 if I'm reading this right. It is not. Oh wait, no. Data rate. Data rate. People use different words for the same things. Data rate, data block size. I do have 16-bit stereo source. Riff file size, wave format. Length of format data. Oh, length of format data, I see. Type, number of channels. So format code, number of channels. Sample rate. Data rate. Rate. Bits per sample times channels. So block size comes before bits per sample. Alright, so block size is bits per sample times channel divided by 8-bit, 16-bit. I care about block size, it's a derived value anyways. Bits per sample. So this, I am hearing, oh, hold on, format has 16 bytes in it. We used up 2, 4, 8, 10, 12. 2, 4, 8, 10, 12, 16 would include the, I'm getting two different file formats going here, so what's going on? Riff, file size, wave format, 16. CM, 2 channels. Just see what we're getting. I have 2 different specs I was looking at, and they do not agree. Yeah, in bits per sample comes expected block size. Which we'll take from here. Bits per sample times the number of channels. Let's see what that is. Expected data rate. That's not right. That's not right. Somebody's lying to me about the wave file format. I don't like it. 1 through 4, 5 through 8, 9 through 12. I hit format. 16 bytes. I know the PCM and channels and sample rate look good. Sample rate. The next value is data rate, which is not giving me the correct number. And that's not, I don't think, the correct number. So it's bits per sample, 16 bits per sample. Oh, no, 4 bits per sample. Size, format, number of channels, average bytes per second. Sample rate, samples per second. sample rate is here. Oh, the sample rate need to be 4. That could explain why everything is way off. Okay. Let's see what that does. Okay. Block size is 4 bytes. So we have 2 samples. Each of them is 16 bits. Good. Data rate, expected data rate match, and the block size and the expected block size. Good. Okay. Now we're in bits per sample. Now we should see the data chunk header next, is my theory. So basically, this is the instructions on how to read the data chunk. Fact chunk is used if we're using compression, but right now I think everything we've got is raw data, uncompressed, so should be good. Back up here. Break. See that data chunk. Okay, that's doing strange things. So bits per sample. Let's see. Okay. Well, we need 16 bytes, so 8, 10, 12, 14. Two, 2, 4, 8. Oh, what's that? 2? Okay. So 2, 4, 8, 12, 16, 20. Hmm. 2, 4, 8, 12, 14, 16. Okay. So that should indeed be the end of that chunk. Return the offset. And then as long as the it's not giving me the chunk. Data size offset. Interesting. The new offset. see. Adding too much. Don't need to. Format chunk. A data chunk. Okay, so data chunk, data chunk. Size. Okay. Sampled data and samples. Samples. Um, I know things were broken up a little awkwardly, but short circuit this. So the data chunk. The padding byte if n is odd. Okay, that's something we can play with too. But I don't know that we need it. Number of samples is 0. Well, that's awkward. This chunk doesn't make any sense. Oh, that's the chunk size. So it's 31K, 31.5 kilobytes. Number of samples. While I'm thinking about it. And insert at the data rate is equal to that. And insert that the size is equal to that. So the program will basically stop and say, nope, these were not the same, even though they should be the same. Okay. Data chunk, where are we at here? I need to. Number of samples. Plus equals 4. If num samples. If it is on pad byte, I don't know if I really care about that. We're gonna skip the pad byte for now. And then the number of bytes should just happen. Data. Sample data. Okay, I see what's going on here. At this point, the data in the offset is the rest of it. So the question becomes, here we have data equals size. That should just do it, right? I shouldn't live forever doing weird things with chunks. It does weird things forever with chunks. Why would it do that? Data. Should that put me at the end of the file? Here's my data size. Data size. 32. 568. What else is going on in here? Okay, so 31 is the size of the data chunk in bytes. 2 channels, 16 bits per sample. So that's 32 bits for 2 channels of data. 500. 32. Not even the normal number of samples. Unless that is in samples or not. PCM, channels, bytes, data, chunk size is m bytes times n sub c is channels, so bytes per channel times channels times blocks. Bits per sample, 2 bytes times 2 channels is 4 times number of blocks. What's the number of blocks? So what data at the end? Riff, chunk size. There's no fact. It's not extensible. So what other data is in this file? So let's write some more stuff here. Chunk at some offset. Let's get the offset in here. Usually I have better luck generating files, but it's kind of the opposite of today's task here. chunk offset 12 is format. Format is 16 more bytes. So it'll be 28 plus the 4 and the 4 for the ID and the size. So 28 plus 4 is 32, 36. That is correct. If we take 36 plus 4 is 44, plus the data size, that would be 31,544. So why is my file size bigger than that? The chunk size is 8 short because it read the riff and the chunk. Grab the wave. Chunk format, add offset 12. Add 16. Oh, come on. So, see, so it is adding the, so it's the 31,544 that I would expect. I would expect this number to match the file size. 31544 should match this. So what's being added into my file? It just looks like junk. None of those are valid, so my children are being loud and obnoxious. Let's see. It does contain a space, 65, 57. Is this a chunk I don't know about? This does look like a valid chunk here, 63, 75. Where's my ASCII table? 63 is lowercase c, 75 u, 65 e, c, q. So I'm getting chunks that nobody's told me about in the basic. Okay, so a Q point identifies some significant sample numbers in the wave file. See, that doesn't, I don't know. Yeah. So there's Q data being embedded here. So we're just going to skip any chunk I don't know about. Let's skip it. That's what this should do. Well, I don't think I'll get a fact chunk. Hey, nice and clean. Okay. Then we get a couple other sections. 4C, 49, 4C is a capital L, 49, capital I, 53, capital S, 54, T, list, capital L list. So that's probably the playlist. There's probably an associative data list and okay. So yeah, it looks like we're just getting more chunks. Looks like we just skip them. Okay. Here I think is the riff values. The contents. 0. I think we'll do that. Okay. We have the chunk size. File size in this case. Then we do a similar thing with WAV. Make it better. Is this. So as long as all my data files have the same format, I shouldn't have to do much more processing than this to get this embedded into my data. Eight, 16, okay. Okay. So we're just gonna handle format and data. Otherwise, it's supported. Chunk. Taking. Chunk ID. It's a couple different ways. ID. Dirty. By 8 bits. 16 bits. And shifted 24 bits. Just to see what we get. Okay, that's not very good. wrong key. There we go. Try that. Yeah, it's reading list, queue. I don't know what that is. 93. Cool. Okay, so it's so as far as the format goes, all I care about is it 16-bit PCM? I'm just going to start requiring it. Read. Skip that. Okay. Required format code is going to be PCM. Required number channels equals 2. Required sample size will be 2 bytes. You can check all those here. Cert. Format code equals required format code. Assert on channels equals required number of channels. Because, oh yeah, sample rate. We're going to assert sample rate as well. Sample rate. We're going to find up here. Be 44100. Okay. Data rate. We can read it and assert later. Block size again. Bits per sample. Should be what sample size is too, yeah. Required sample rate times 8 bits, because I'm doing it in bytes, which we can change that. 16 bits. 16-bit pre-CM, that's all we're gonna deal with. Assert those things are correct. That should give us enough data. Skip all over all chunks that are unsupported. Okay, so that data chunk. We're just gonna save the handle into that. With offset plus 8 bytes. Okay, so the things we are going to now do. Once we make it through all these assertions, we know enough about the sample data to just do the thing. Oh, we will need to save the data chunk size. The other piece we need to store up. equals chunk size. Okay. Yeah. So these two pieces of information out of the file. We assert that the format is something we support. Let's say equals. Equals. You get the file size. Equals true. All right, just a bit of tidy up, clean up here. If this is wave, I'm just going to assume that the size is correct. If the result is true, okay, we're almost there. We're almost to the point where we can start writing stuff to the file. We want to write to the file. These are the two pieces I need to write everything else. So we're just going to cheat. We're going to make global variables because this is small and it's simple. Okay. So we've read the file, we've captured the few pieces of information we need. Now we can write to the file. Oh, go check my phone for just a minute. Okay, and we're back. Okay. So at this point we have data offset, data size, we have a handle to the data, and we know that we are PCM 16-bit and 441 hertz. We don't have to do anything else from there except write it to a file. So what I need size mode. Do I remember what that means? Oh, image. Switch small bytes. And for each file, we're basically going to do this. We're going to say read the file. Check the riff and the wave. If it's an actual wave file, read all the chunks. The chunks will check for valid operations and capture the data offset and data size. So somewhere, I have a right to bin. Be out file key, which I'm getting in this lambda here. Index. We passed in. Our data will be data plus the data offset, and it will be data size. I've already written a helper function for that. And that should be it. We set the data size equal to the data size. Where did this data size come from? Oh. I'm going to change some words around. This data size is already being used. Offset sound size. Okay. Well, let's see how this goes. Nope. Oh, comma in instead of equals. That's not very good. Yeah. Suppose. Oh, file declared void. Oh, there we go. That's a little silly. Okay, now we see what we get. Logging that. Okay. Where's that error coming from? Output file contents. And I get the key, I get the name, and then the function that I built up, that lambda, and it has to return true. So, oh, am I returning true? Result is false. If riff and wave set result equals true, if I know it's a wave file, process things. Oh, it's not even read the file. Returning false. Alright, more logging needed. No, not text file. For sure on the view binary file. Wave. So we get some more logging information. It is not a wave file, which seems odd. Problem. Indianness problems. Forty-six, 49. 45, 56, 41, 57. We'll swap the bytes around. Now maybe it'll get an actual wave file. Hey, okay, assertion failed. That's better. Oh, bits per sample. That's not what we wanted to test. Size. There we go. Since all of the sounds I have come from a common source. Oh, cool. I should have that in there now. So let's take a look at source file. Oh, source sound warehouse. This should already generate a bunch of stuff for me, right? Get data. Oh, not width and height. We'll look at that. Get key, get index. Widths. All right, that's one thing I'll have to look at. But in sound warehouse, let's see. I can get data, get the size. See, f underscore sizes should be in the header. Oh, how about an line? Embed waves. Yep. There we go. Bytes. All right. There we go. Now magic should occur. We run it. Then we can open sound warehouse. Now it only has size, not width and height, because these are not images. Sound warehouse does VPP. Get key, get index, key index map. So, yep, very good. And there's click.wave binary data. It's actually mostly zeros. And it's 32,000 bytes. Cool. So what we have to do then is add it to a makefile. Font warehouse, image warehouse, shader warehouse, sound warehouse. And let's see if it compiles right. If it does, we check it in. And then we start playing with the sound playing side of it to properly select the right data from the sound warehouse and pump that into the buffer as needed. Which will be a little bit different than generating a waveform from scratch. But not too hard. So the sound warehouse did compile without errors or warnings. That's good. It's up there. So the reason we went through that whole exercise with the C file that parses a file, that opens each file and checks it, is I'm going to be adding a bunch more sounds. There'll be a warning when you type something wrong, like a double character, or try to type more than 5 characters, or try to submit a word that's less than 5 characters. We need a losing sound. You're a big loser because you didn't guess the right word right, ran out of guesses. Then another sound for victory when you guess the word right. And maybe like another victory sound for you've completed your run in sprint or golf mode. So we will be embedding more sounds. And if I do this all now, my next project I can just copy and paste and move everything over and extend it as needed, but yeah, compiled. Cool. Source builds debug, and it even runs. with that sound warehouse in there. Cool. All right. Cool. We can eliminate some more letters. Okay, the word prime. We're going to make copies of the number 1 deduction space into 2, 3, and 4. I'm going to assume the following in that one, that one, and that one. We'll see if we can create contradictions. So in the second workspace, daemon outlimits limits a lot, and rhino is a contradiction. So this one is not a valid letter combination. M and R cannot be in the same word. Over here in workspace 3, that also invalidates rhino, so this is also invalid. Lines invalidates rhino. What's going on here? Why is everything invalidating rhino? Let's clear this. Let's just copy all of this. Let's go with RN and not O. R, not N, and O. Not R, and then O. Okay. Those are done. These are done. And that's a big contradiction. No U and no D. All of those are in. That creates a contradiction there. Daemon is already invalidated. I think we just need to start over. 1, 2, and 2. So all those letters are out. Oh, I know what I did. Wrong deduction based on laced rhino stump. Okay. Now we come over here to prime. Copy this deduction workspace into 2, 3, and 4. 2. We take R and I, but not E. Take R, not I and E. And not R, I, E. There we go. So rhino and lines, daemon, A, C. Okay, so that's a possible. None of those. None of those. H, that's an invalid one. That's also invalid. So it has to be acrid. Hey, did it. Goodness. Okay, so BD, interesting. Logs, jacks. Huh. Waxed. Okay, so those rest of our letters is in F, G, and WX. Wings. Perfect. Lunch toads. Demon. Beast. Rhino. Wings. All 3 of those are in. Out. E. Logs. Jacks. Waxed. Interesting. A is in, and B or Y. With fives. Oh, hey ho, Raider. What am I up to here? Hangman. Nah. The skeleton behind me was my last coworker. It's Wordle-ish. This is an homage to a game I played back in the early 1990s, and he yeah. So basically, I'm trying to make a game with no game engine, make it small, compact, pull in no dependencies that I don't need. In fact, you can see the dependencies there that I'm using. They're all listed out on the output, the console. And then I'm just trying to make everything as small and compact as possible and embed everything inside of the executable. So it's right now it's called Word Sleuth. The old game from the 1990s was a Mac game called Word Breaker. You don't get any positional information like Wordle. So yeah. So what's with the raid? Thanks for the raid. I don't know what I'm actually new to raid Twitch. I don't usually watch Twitch or participate much in Twitch, so yeah. So I'm using this as a learning experience. So I get into the OpenGL, write some shaders, write some low-level code. Really interesting. Cool. Well, I'm glad somebody appreciated my stream a little bit. Yeah, so where I'm at right now is I have sound that I can send out pre-computed waveforms like sine waves, sawtooth, square wave, triangle wave. And what I'm trying to do is embed recorded audio inside my executable, which I just got done. And now the trick is to get the playback to grab that binary data out of the executable itself and play that instead of these really bad sine waves. So if you have questions, if you want to see anything or get an overview of anything, let me know. Otherwise, I'll just be talking about whatever. But I figured I better play a little bit. If you don't play your game while you're developing it, you're no good, right? So for those who are new, the reason I start with these 3 words is that these are 15 unique letters, and the answer can't have any duplicate letters. So I know that all 5 letters are in these 15 letters. So all the letters that aren't in that collection can go away. In fact, I have a shortcut button because it's such a common thing. And these have the 15 most frequent letters in the word library. And then I go with ultra, demon, and there's a 3rd word, chips. And ultra demon chips is an exact anagram of lunch prime toads. So I know without typing that chips has 1 letter match. Ultra demon chips, then I do laced rhino, stump. Stump is another anagram of the same exact letters. So I know stump has 2 letters without having to type it. Then proud, lines, match. I don't have to type match. I'm just showing you. Proud lines match is another anagram. So I basically have different combinations of these letters, right? And in this word, D and E are together in these ones. But here there's no D. And in proud, there's no E with a D. So I get all these letters mixed and matched. EAD has 1 letter. And EAD is here with 1 letter. So LC must have 1 letter among those 2. So it cannot be U, N, or H because the LC already uses up the letter here. So we go ahead and cross out those. Let's see. Oh, lucky guess. So all the 3 gray letters can be turned green in 1 shot, which means all these gray letters can go red. And these gray letters can go red. E or A. T or A. E or D. Oh, E is out because of lines. So A is in, M is out, and there's my 5 letters. So No, it doesn't recognize salam. Let's see, what is it? What word is it? Somol, Mosul, Moles, Moles? Anyway, that's basically how you play the game. I use WAS API. Yeah, exactly. So let's see here. WAS API. Nope, I'm not using Windows. I'm using just MSys to give me everything I need in like an MW environment. So in the future, if I want to port it to Linux or Mac, it won't be too hard. Yes, exploratory testing and deduction. Yep. So it's fully functional. It's feature complete. What I'm working on right now is making things sound better. Then I'll throw in some crappy developer art. I'll add some animations. Like I'm basically making it look nice at this point. We're kind of through functionality. It's all there. So, I know what all the letters are. I just need to figure out what the word is. Maybe the S is at the end. Lamos. Malos. There we go. Oh, it doesn't know that one. Gnomes. There we go. Not a word I use often in conversation. Brain doesn't see it immediately. Okay, so I know that of these 15 letters, 4 of them are in here. So Ultra Demon Chips does not have any letters because we can see that without having to type it. Place Rhino. Stump has one. NO are in, D is out, T and A are in, and we don't have to do any more with those words. BD gets me the 2 next most frequent letters in, and since it's B or Y, we know the 5th letter, and everything else that's not B or Y can go away. So, maybe we can just prove that it's black. B. Baton, that seems good. Oh, we're almost through the run. On a speed run, you have to guess 6 words, and the timer starts when you first start typing. But there's a marathon mode where there's no cap on level. You just go forever, and that's the only thing that matters. And then we have a golf mode where you go to level 9, and you try to get the fewest number of total guesses across the whole run. Hey, thanks for rating. Appreciate it. Thanks for rating me. My style is C++, but mostly C. C almost got everything right, but not quite enough. And then C++ added too much junk that I don't want, so C with some C++ in there. So yeah, thanks for stopping by. C++ doesn't have a nice way to embed data. How do you do it? Okay, all right. Here's the secret sauce. Are you ready? We just went through tools, embed, waves.cpp. So what I do is I open up my sound files. I get a text file full of the sounds. I load up each file, so read the file as a binary file. And I've written a function for that, so don't worry about that. And then for each of those files, I read through the file and I gather all the data I need, and eventually I do write bin. So if you look at my common, like there's just a lot of manual code emission. And what you end up with is something like Sound Warehouse, where it's just a dictionary of file name
to index, and then I can get the data at that index anytime I want, or I can get the key name by index, and then I literally just wrote this string out, so it's just embedded byte array. That's all it is. Ain't pretty, but I don't think you can do it any other way in C++. And yeah, it's a hand-spun solution. I think there are fancier tools for like templating that does a lot of weird things at compile time, but I prefer to just write a tool, does one thing, gets it done, and now I have that data embedded in a byte array. Hope that answers your question. Yep, exactly. So what kind of stuff does my Raider come from? 9 codes? This might do slightly nicer is put the file in a different directory and getting order to make it clear that it's build artifact, not source code. Yes, that is fair. That is not a bad way to do it. And if there were multiple devs working on the team, I would definitely do that. It's probably not a bad idea to add to the output. Let's see here, a comment at the top, like, yeah, so I can put a comment here and be like, don't edit this file. But it's kind of unnecessary as I'm the only dev. But it's a good call out. I'll put this in for now. There, and that should do it. All those files should be marked. I possibly prefer tinkering with the delivery pipeline to building features. So it depends. Like, especially as a solo dev right now, I prefer to hack away at something until it becomes a pain, and then I'll go build it into the pipeline. So it's kind of a priorities thing. If there's more devs, I would definitely spend more time thinking like, hey, like you said, put in a separate directory called gen code or something. But since I know every line of this code, I'm not too worried about it. Case of question, actually. Oh, let's finish my run. Actually, let's just surrender. Boom. Oh, it was drawl. Too bad. One thing I want to do is look now at my number of lines. Okay, son, go play. Look at the number of lines. 27,000 lines of code, but the image warehouse, the font warehouse, and now the sound warehouse are contributing 15, 16, 17, over 17,000 lines of code. So I'm just about 10,000 lines of code that's going into the executable. Check out non-codes and see what kinds of things he streams. Or she. Because that was very nice. Very nice. What was that? Slow count? Oh. No, this is just word, just simple Unix word count. It does not look at comments. I don't actually comment much when I'm a solo dev. Generating 18, 19,000 lines of embedded data. That's going to grow as I add the bad developer art in. Okay, so how is the test? Sound warehouse. And for now, we're just embedding a waveform, like sine, square, triangle, sawtooth. So none is going to be what I use. Time themes. Yeah, we could maybe make things fancier here. So what we want then is a way to get the sound by index. If there is no waveform, it should try to look up a sound index. I think that's how I want to do it. So we can do things like this. We're going to start looking up that information. And I think we might want to sound name. Learning web development, mostly backend building a shared music YouTube-based playlist app in Node, Express, Postgres. Okay, okay. Got it. Web development, I have done a little bit, worked for Amazon for a bit. I don't much care for it. I'm trying to get like lower and lower into the metal. Like for the example, this game literally had no engine, minimal dependencies, and I think I could get rid of 2 if I put in the time. So I've been trying to move lower and lower into the tech stack, closer to the metal. But mad respect for people to get into web development and can keep track of those tech stacks. That's unbelievable. Raylib in C. I have not played with Raylib in C, but I've seen some cool things done with it. Awesome. Okay, so sound. What other things we're going to want to do? This one. Okay. We'll copy for now. Change it as needed.
Daddy?
Just a moment. Let me check. Let me go mute for a second. What's up? Oh, okay. Yeah, JavaScript. I find there's just too many layers of abstraction for anybody to actually know what's going on in web development. And like you said, JS libraries are just nightmare to work on. Drop the GLFW and glue dependency, and you're golden. The 2 I really want to get rid of are the GL math. It's way overweight for what I'm doing here with 2D stuff for now. I don't think I'll get into 3D until maybe my 3rd game. Like these are small games to keep them simple, like to limit my scope so I can get them done quick and just do the learning process. The other one is the font rendering. I've watched some videos on font rendering and it looks like it's a lot of bookkeeping, but shouldn't be too hard.
I need some keys. Mom took her keys.
That's the way that.
Okay.
Yeah, if I get rid of GLFW and glue, Then I'm back to using Windows APIs, and I've been resistant, probably because I've spent much of my career in Linux and Mac, and but then you'd have to write everything from scratch for each of those. And frequency, duration, it's running. Like it doesn't matter what I set those to, so it doesn't matter. But the important thing is we want to get that sound index. Going to equal the sound warehouse. Get index. Of the sounding. Now I don't have to store the sound name at all. I just keep the index. Even easier. And in the string callback, the waveform is none. Oh, already got enough here. If data point to sound index is greater than or equal to 0, we do something, otherwise we can just pump 0 out. Okay, so this is where we have to look things up from the sound index. So what are my viewers working on? Any good projects? So this is one I've got. I've already decided the next game after this one I'm going to prototype out. I'm going to make an homage to called Continuum. A little more dynamic, a little more world scale. So that'll push my tech abilities out a little bit more. And then my third game will start being where I think I'll have the basic tech skills in these levels to do a better job at something cool. Sometimes I work on like a compiler technology stuff. I might do some of that Friday. I like designing board games, tabletop games. I've got one with a good amount of work done that I've prototyped, play tested a few times. Another one I prototyped once for a tabletop game. Got a game that I want to make in like a tabletop skirmish that I've not prototyped yet. So get database on the index should be really fast. So I'm not worried about doing this every 256 samples. So what we need also, okay, is to set this to something by default. And we need more information. Sample offset. And I think that's enough because I can use the index to get the data size. So basically, where at the in the side the recorded sound am I playing right now? E equals data at data point to sound. I forgot what's called, sound sample offset. Divided by 65,535. Yep. So that should be fine. So that'll move along the sound sample offset through the data. Okay. 65,535. No side project. Oh, charity. Okay. Cool. I'm not gonna pop this open on stream because you never know. Checking PHP libraries. Oh, backwards compatibility. Oof. Yeah, that's tough. Everybody wants to change things. Okay. Changes in enums. Nice. I don't know. I found over the years that I just kind of needed something more interesting than work could provide most of the time. A lot of times work is pretty dry or so like meeting driven, like requirements gathering and validation and whatnot, that you can't actually get much coding done. So maybe that's just the way that my career went. I'm assuming there are places where those requirements and meetings are worse. But there's also places where it's better. So so a couple more things we need to do. Okay, I know what I need to do. Found warehouse. I need to see get size. Yeah, get size is a unit 32. I could store these if I think that this is a performance concern, but these are array lookups. So I'm not actually that worried about it. If it does become a problem, I can cache those to when we load up. Actually, I can just now. I'm just get it working. Just get it working. That's what I'm gonna do. If sound sample offset, that sample offset is in bytes. Which we actually don't want. We don't want char star. We want unit 16. So we are going to type on it, and that's okay. We get the size divided by 2 because it's not bytes, it's now 16-bit words. If the sound sample offset is greater than size, that's then equal to size, otherwise 0. There we go. Now, this is all pretty blind. Hopefully it just works. I've only been working with port audio libraries for a week or two. Most places are like that. Yeah, so people ask me why I quit Amazon. I got a perfect task that exemplifies everything that was wrong with that world. It was, hey, this page over here, you need to add a button to it. And this is not even customer facing. This is like, well, customer. Not like the storefront customer facing, right? This is the third-party vendors side of things. And so, yeah, story time. So I get this task. We need a button here. When you click it, it needs to pop up an overlay that has this message in it. Okay. Who owns that page? I don't know. Oh, okay. You know what repo it is? No. Oh, I don't know. Okay. So you go to the page and you find a piece of text that you think might be unique. And you put that into the translation service and say, what keys translate to this text? And it'll find a key. Then you look up the owner of that key, who created it, and you message them and you say, hey, do you guys own this page? And they'll be like, oh, well, we used to own that page, but now it's owned by this other team. So you go talk to this other team and say, hey, do you own this page? And they're like, yeah. Oh, okay. I need to put a button here with a pop-up. Oh, well, we don't own that panel of the page. We own the whole page, but this other team does this thing. Okay, so I find out who that team is. I go talk to them. Here, I need to put this button in that does this little pop-up thing. Oh, okay. Well, we'll give you access to the repos, and you'll have to run your code reviews through us, and all that jazz, and tell us when you're going to deploy it. Okay. So I go through. I finally get access to everything. I write the code. It takes about 4 hours of work, right? 2 hours. I had to write some unit tests. Get it all done. Submit it for approval. The team that owns the panel had to approve it, and the team that owns the whole page had to approve it. So that was some back and forth there. Finally get it done, deployed, done. That took me 2 weeks to get 4 hours of coding done. And it was all like that. We had one guy, he had to request permission to some data. And to find out what that data was, to request that data, he had to do an audit to find out where that data came from. Like it went through this whole pipeline of different databases and services. And he grinds through it all for a couple of weeks. It's a painful process. And he finds out that data, it comes from our team. He owned that data in the first place. So why is he requesting access to it? The whole thing is like that. It's just a big mess of meetings and spaghetti because nobody can hold it all in their head. Good times, good times. And partly I'm stalling. I don't know if this is just going to work or not. I hope it does. Oh, where's the reset? Reset. 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 Where's the reset? There it is. Signal data dot sound sample offset equals 0. There we go. All right, is this just gonna work? We're gonna do a full clean rebuild. Yeah. But I guess you can afford all that inefficiency if you're willing to throw money at the problem like that. Opposite problem. Oh. Yep. Small teams have their own special problems. So 3 devs, what do the other 10 people do, or the other 7 people do? Like I've worked for some small places. Like just while I was in college, I put myself through college by working for a little scientific equipment developer, and like everybody was an engineer. Like there was 2 mechanical engineers, 2 electrical engineers, all designing circuits and data processing. All problematic teams are special. Tolstoy. Tolstoy's on my stack, on my reading list up there. I haven't got around to him yet. I've been reading some Dostoevsky on and off as I can handle it. Russians tend to be pretty depressing in their in their world outlook. Um, one MD. Let's see. Okay. Still seems very well. Yeah. Seems not developer heavy enough, but funding. I don't want to get caught with customer support either, so that's fair. Oh, yeah, I guess. Charities have a lot more reporting requirements. Sound index, which is a non-class. Sound index, sound sample. Why is it complaining about sound index? Oh. Oh, I see. Because I am a doofus. Right, anyways. Lots of less than size. Are we all in office or are you working remotely? Are we focused on a particular kind of charity? In office. Okay. Yeah, I've seen a lot of people go to the once or twice a week in office kind of thing. Just make sure it's still running. Play some golf. Okay, seems to be working. Now the question. So we have the sound. Click, first click, there it is. And we're gonna hide all of that. Or figure out what are my initializations list to put a click after message information. In theory, I put click.wav. Maybe another function I forgot to include. There we go, sound name. Index 0 return sound warehouse get key for this index. So in theory, we're initializing with the click sound. So instead of hearing that sine wave beep beep beep, it should just work. The duration. We don't need that duration either. Free office space, cool. Nice. Funding for those little teams is hard to find. So when I was in college, the little company I worked for, there were about 9 employees most of the time. And at one point, I had one of my brothers employed there as a machinist, mechanical engineer. The other one basically was like stock inventory assembly. And I was there as a programmer. So there's 3 of us, and on a good day, we found we could have had a vote to change the company name to our last name. We probably would have won, but okay, so let's see if so we have to fill the buffer no matter what. If okay, so we just tested this. Down here. Sample count. Let me think about that. Yeah, sample count greater than. Okay. So if data waveform equal to waveform none. So in other words, we're looking for that playable thing, and data point to sound index greater than 0. We're going to check things a little differently. Otherwise, look at it this way. So our waveform is there, and that's that. Let's just do that. Because we need a similar sort of test inside here. I think for just my mental sanity, it'll be a little easier to do the test this way. If we've not gone all the way through the sound. Continue. Let's make this consistent, less than, greater than or equal to, complete, else. We can probably make this all a lot cleaner to read here in a minute, but we just need something working. So if we are in a recorded sound, oh, this sample count. Oh, let's see. Okay. Size. Yeah. I'm kind of wanting to untangle some of this. Do I continue or am I done? Yeah, let me come back and revisit this. Let's see if it compiles. There were no errors. So I should be able to compile that clean. Was it a Democratic company? No. The guy that owned it was very energetic, very scientific, very and he liked being in control, which was fine because he mostly knew what he was talking about. People that want to be in control that are idiots make me sad, but if somebody's really smart, knows what they're talking about, I'm willing to let him run it. Interesting times. We lit a lot of things on fire there. All right. Oh, here we go. Is it a ding, bad sine wave or a click? Oh. Well, there is no click. That's good. Interesting. Ugh. So I'm getting a different sound. Miser. Okay. But it's clearly not playing back right. Or maybe the sequencer is trying to do things to me. Playing the game scene. When we submit a guess, we count the number of matched characters, and then we start up an action sequence and hand that to the scheduler. So we say, scheduler, give us a new action sequence. We're going to play the sound. Oh, there's a duration there. It shouldn't matter too much. And then it should also wait. So it should play the sound, then wait. Then play the sound, wait. Play the sound, wait. Play the sound. But I'm just getting a tick. I assume you all are hearing just a single tick as well. Disconnect and speak. Yeah, maybe I didn't choose the best sound to start with. We can play other sounds. Let's see. Where's my audio? Audio. I closed it. Okay. I had a bunch of sample sounds. Maybe I need to play a different sample sound. I'll just pick one. Let's see here. Let me grab one real quick and dump it in the folder. Oh, that's not that one. Sound, Deftones. Okay. Let's see. with that one. Ooh, that's really high pitched. I'm not playing these for you because I don't know what's gonna maybe come out. Nope, not that one. Mm. Oof. Can I get something more normal? Maybe doorbell. Chimes, clicks. Digi beat. Yeah, maybe that'll work. Okay, we're just gonna grab this one. Open in our project folder. Now, this should be easy. You go to assets, sounds, we add beat, G, beat. I think that's the name of it. Oh, wow. And then we come to game scene, and we get beat. And now we re-embed all of our stuff. So it's building each of those embed programs and executing them. So there's the shaders getting dumped into the executable. I've just got one sample texture in there right now. A couple of fonts just to differentiate some things. And the word library, because I want to change what words there are. Where did... Oh no, I didn't do it. I need this big file. Yep. Semicolon dot slash embed labs.exe. I've got that as my main build process. Kill it. Get back in here. And now it embedded the wave files. Good. Right there. Excellent. So in theory, my sound warehouse. My kids are getting very loud out there. Might have to go close my window. Okay. Play. That's not what I was hoping for. Alright, I'm gonna close my window. And wonder why. Okay, some possibilities. It might not be resetting. Oh, reset. Oh, okay. Sample. Sound sample. Offset equals 0. Except now I have to check for two conditions. The other one is basically if we're playing a sound and we've played enough stuff. Which is starting to get a little messy. I think I might want to change how we do this eventually. So if we have no waveform and the sound index is good, and if we played enough samples to be larger than that, or we've exceeded the phase, so okay. Alright, we can try that. So it's not resetting the sounds properly. Okay. Huh. That is still not sounding good. We may have to update the bookkeeping in sound. Where are we at? Let me think. Reasonably sure that the data is embedded correctly. Is that true? It's this whole mess here that I'm fighting against. Maybe some in here. All right. It's time for me to have a restroom break. And I'll come back and dig in and try to make this a little better. There's definitely some rough spots. All right. I'll be right back. I turned all the things on right. Thanks for coming. Appreciate you hanging out in my chat. Come back anytime. Let's simplify the problem. I've been hanging out in game. What we're gonna do, take that out and put this back in. I'm gonna make a couple changes I want to see anyways. That goes like this. We're gonna sound and we're gonna go play. Duration. Okay. So this. Double duration. Return underscore signal data dot duration. Okay. Okay. Now play. Does not get duration. Okay. Okay. Hmm. Okay. So that's one thing. Now we load a file. By load file, I mean this. Let's go and extend this out. We want sound index. We want int 16 t PCM data, PCM sample count. Okay, so when we get the sound index, we get the PCM data, the sample count, which is this. equals sound warehouse get size. The sound index, the sample offset is there. The duration is going to be x underscore sample rate. So as I'm using s prefix as a static indicator for myself. If anybody wants to know what's going on, let me know. I'm happy to explain what I'm doing. The sample rate is samples per second. I need to take the sample count. Okay. Oh, interesting. Okay, so I already have some ideas what's going on in here. So I'm going to say get size, that's in bytes. Divided by 2, that's the number of PCM samples. But I want I actually want to divide by 4 because I have 1 sample per channel. So it's actually 4 bytes per 2 channels of sample. So I divide by 4. And then the number of samples divided by the sample rate should give me a time. Here. Equals null and pairs with PCM data. Okay. Samples. So that's it. We need. Okay. Max samples. If the duration is greater than 1, it computes sample rate times the duration. Okay. So that should be fine. That should be fine. I don't need that here. Then. Actually, a lot of this isn't too bad. Let's do this a little differently. Left value, right value, left, right, value, right value. Because these are interleaved, I get 2 consecutive sample offsets. Then I get my left and my right. L, 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 L. Indent. Left, right. There we go. And then that's a sample. Once right, left channel to the right. Okay, so that should help a lot in some places. And in fact, this whole chunk can go away since duration is now handled by the sound file itself. Cool. Which means this complication can all go away as well. Make sure that builds. we'll probably see. We're gonna put it in a different area. And interesting. Yeah, I did put it in twice. Interesting. Oh yeah, I remember. Data point two. ECM data. Data point two. TCM. Sample count. There we go. Huh?
Can I pick up pizza?
Yes.
Daddy, can we all three? Daddy?
What?
I'm gonna say something.
What's that?
Can we have
No, right now, no. Oh, I know. What's that? Children, they're so cute. Good thing I have a will of iron. I'll put your- Hey, here. Oh. Okay. Oh, awesome, awesome. I think my chatting is starting to slow down because I'm getting tired, but I really want these sounds to start working today, so. Duration still not properly labeled. That is within single data. Full rebuild. So, chat people, or all the rest of you software developers, I was listening to what's his name? Day 9. And he said a streamer has to say something interesting every 15 minutes or 5 minutes or 15 seconds, or I don't remember. So, as a new streamer, I'm trying to figure out what people find interesting. For me, I like watching those. Well, sometimes. Sometimes I like watching. I don't actually watch that many streams. I like watching after the fact. People that have uploaded a whole stream to YouTube or Rumble or whatever. It's actually what I'm doing. I stream and then I'll upload it to YouTube and Rumble. But I like watching like full unscripted programming sessions. So I'm just curious what other people find interesting. What I'm doing right now is what I find interesting, which may not be the best way to May not be the best way to build an audience. Nope. While I'm running through some debug cycle here, like interesting words, words that make me laugh, words that are fun to say. One of my favorite words of all time is hippopotamonstrous esquipedaliophobia, I think is how it's said. It's the fear of long words. So it's like the most ironic word. You go to a psychologist, you complain about all the problems you have, and eventually he says, got a diagnosis for you, but you're not going to like it. It puts you right in a panic attack right there in his office. It compiles. Okay. We should be back to the bad sine wave dings here. Whoa. Okay. I did not change something back, right? Nope. I know what the problem is. All right, let's go back to. This is why we test quickly before we move on. Set duration 0.3 or something. Oh, 0.3. 0.3. How long do I have the weight going for? Okay. Try this real quick. Hey. Okay. That's not too bad. We'll move on with this. What we're going to do is we're going to go to a different scene. Instead of trying to debug things in a complicated game environment, we are instead going to make a sound right here. Sound. That's after. Click. Click dot web. Okay. All we're gonna do is set it up. If you click that one, it should just be ready to go. So if input is key pressed, input key space, underscore click dot play. So in theory, I hit space and it plays. It should finish. It should do everything it needs to. So let's go to sound. Let's see here. I'll go to play. I just want to see things happening here. And I'm not going to test the other. Fine. Pause, reset. That should be enough for me to see what's going on. Oh, I might have to clean out. I wonder if I can just. What real change I made to the about. Source about scene dot. Oh. File. Sometimes there's hanging artifacts that make things awkward when you change the header files. Okay. We'll go to about. Okay. So hit sound play, but it never went to end or stop. So. And then it died, which is fine because I sort of expect that. Is that true? That's actually a good question. Where's my destructor? Pause. Close the stream. So it should not be playing when it's destroyed, because I assume that's what's happened. It was trying to reach that callback at the time of after the destructor ran. Well, I'm not as worried about it, except the fact that it's not ending. Go back down to play. Just see what it says. Let's see. Gotta answer the phone in just a minute. Okay, I'm not interested in phone salesman, so that was quick. Back to work. My duration, we can print that out. Let's just print that out. Iteration. Let's give it 6 decimals. Why not? Dot duration. When I go to play, this can go in set duration. And then do that. Set duration. If the duration is greater than 0, we calculate maximum sample length. Okay. All right. Let's see what we're getting. So yesterday I had a Brazilian, I had an Indian. Anybody here from not the United States? Or from an interesting part of the United States? About. Interesting. Duration is 0. The maximum samples is going to be 0, which is why it just clicks and goes forever. All right. Good to know. Oh. How about if we not do integer truncation here? That would be wonderful. Although, well, I guess the frequency is also integer, huh? Yeah. Okay. That should help. It might actually work better now. Aha, now it has a duration. Oh, and it crashed. Interesting. And it's still not working. 8,142 samples at 44,000 samples per second is about 1/20th of a second. Okay, that tracks. Okay. Let's back to sound. If the maximum number of samples is positive, and if the sample count is greater than or equal to the maximum number of samples, it should go to complete. This thing sample count. Okay, so that's all fine. We don't even need this really. It's already done here. Does increase my sample count. Maximum samples has been set. Yeah, it's 8,000 samples over some duration. Waveform is none. Sound index is a real thing. I say PCM sample count. Oh. Okay, that could be a problem. Maybe. What's the PCM sample count? Yeah, right there. Okay, so that needs to be two channels. Go. Okay. So basically, I need to count relative to the PCM sample count, which is all of those, but the max duration or saturation. And so this is just bytes to short. And that's, yeah, so what's probably happening is we got to here, and we only went over half the data, which means it started filling with zeros and not incrementing this sound sample offset. So what I might do is this. Sound sample offset is equal to that way, whether we fill it with a 0 or not, it'll still advance. Just in case that divide by 2 is a problem. Divide by 4. All right, we go to about, and hit space. And it did not stop where it ended. All right. It might be that we're getting a different signal out though. So maybe reset pause. Yeah, let's see if that works any better. No, it's crashing. Sugar time, run. Did not crash. There's the play. It's not finishing. Yeah, he blocked past it because it's still trying to pump data into that buffer. Oh. Hmm. We're not sure what's happening here. It's never hitting the end. Oh, I guess we could. That's the other things here. Like, so have the number keys set to different notes. While number key is pushed down, it'll continue to play until I let go. So those are working. We're going to about CPP. What if we do this? Go to set duration. And then for each one of these, oops. Oh, okay, F3, search forward. Delete 2.25. Alright. So instead of it being down the whole time you hold the key down, it will set a duration on that key. So that when I push the number 1, it only stays active for 1/4 of a second. Let's just see if that still works. So go to about, and it crashes. Check sad, and it's still crashing. Nope. Duration is no longer being honored at all. Yeah, it's some crap. I broke something. Duration used to work. Now it doesn't work. Hmm. Sample count gets incremented every single step through the number of frames per buffer. The maximum samples that's being computed here, right there. Let's see what that does. load up. It's probably me being silly. Okay. Oh. Interesting. So, oh, okay. Let's just quit. Let's do this. Boom. So I expect a whole bunch at first to be 0, and then I'd expect this one. Okay, and then I have the maximum samples. Yep. Okay. Input. Okay. Maximum samples is less than 0, or sample count is less than maximum samples. Data. T. I don't need T. I can use it in the other verse. That's fine. That's that much. So what's going on here? Sample count gets incremented. I know the maximum number of samples. If maximum samples is positive and our sample count is as much as, then we can pop out incomplete, which will trigger the end stream callback and tell me these things. Maybe just clean and debug. Just do a full clean rebuild. Weird in one of the linker files. When I start getting bugs in areas of code that I've had working solidly forever, usually means that like the MSVC memory is wacky because it got the wrong object size from something else. Run it. Okay, in about definitely have maximum samples, and I definitely have duration. So it's not stopping. And then that one just is no good. Duration is not being honored anywhere. That makes me sad. Okay, well. Let's see here. The code here is so simple. So, set a duration. And if it's greater than 0, get the number of samples. Yeah, duration max samples. I play. Call reset. Reset. Reset should set my. That's in both constructors or in stop. Reset. Sample count. Sound sample offset. Start time, elapsed time. Reset. Sample count is being incremented. This does not change the maximum samples here. Samples greater than 0. Yes, it is. And if the sample count, which is always incremented, is greater than or equal to the maximum samples. What is going on with this? PCM sample count is not the same thing. That's fine. Reset. If maximum sample is greater than 0 and data sample count is greater. So if we've reached the end of the buffer, it's really this question. The expected playtime, we perform a reset. Otherwise, we just pause. Okay. We compute T for the parametric waveforms using sample count. But we don't need to worry about that. Because it shouldn't matter. Get our samples set to 0. Default. If maximum samples is less than 0, or so if we're not at the end of our play time, that's fine. The sound. Set the left channel, set the right channel. increment sample count. I don't see any reason this should not increment that value until it passes up. It's right here. Every single one of them has a maximum number of samples. I said a quarter of a second. That's out of 44,100. That is a quarter of a second. So they should play for a quarter of a second and not for forever. But they're playing forever until I release the key. Why is that? Samples and needed. Ugh. Confusion, disorder, chaos. This has a duration. There's the one for spacebar. Here's all the ones for the number keys. Over to number keys. Ah. Ouch. Okay, well, one thing we can do is make it so we can do things. Underscore click is play. Stop. Play. Okay. Up to the left, right. Number keys. Okay, what about this? We don't give ourselves a way to turn them off unless we're really serious. Those should. Unfortunately, it's a little hard to run in the debugger because it's in a separate thread. Because the port audio makes those callbacks in a separate thread. Which is a problem. I mean, thread safety is wonderful and all, but what we're going to do is we're going to make it so that the spacebar just always turns off. All the sounds. See what happens. I like this. This used to work. It's working at this. Okay. Parse working yet? It was definitely working. Wait. Did we not just listen to in game the? Nope. And it's just broken. Okay. And it's never getting to the end stream callback, which means it's never returning PA complete. Which means what? What does it mean? Sample count. Well. Okay. If data point to sample count equals 0. So this is the first time we're firing up this full callback. Samples. Give me the max samples. Log of the thing. So if it's the first buffer, we're going to say log of the thing. If log of the thing sample count should be data point to do it this way. Do sample count over max samples. I should have once per sound start operation. Bit of a quiet chat today. Oh, what? Sound.play maximum samples -1. Despite the fact that here, this is the spacebar sound. That says 8,000. So something's doing something weird. Okay. Who's assigning to max samples? So that's why it's never finishing, but oh, in play. Who's setting that in play? I'm a doofus. That means basically all of these log messages need to go away. When I took out the max sample count from play with duration, I left the default value in. Actually, let's get the whole log thing. All of this goes away. It's the problem with streaming. It is harder to keep track of things. Once you find them, you're like, ah, that was dumb. We could have got there so much faster. Error note. This one, yes. Okay. That should all just work now. That's embarrassing. Can't see what's right in front of your nose. We're trying to talk at the same time. So these should only last 1/4 of a second. Yep. Okay, and this one is not sampled correctly, but it is starting and stopping. So, whew. Back to this thing. We're gonna get rid of that. We're gonna get rid of this part. That shouldn't matter anymore. Right now, duration working as expected. Okay. Now, it doesn't sound right. That's click. So let's do beep. Maybe something different. About, so. Ooh, that sounds terrible. Ooh, I don't like that. I do not like that. Hopefully everybody's headphones are not turned up too loudly. Whenever we work with audio, that's a different risk. Set duration. Try that quick. I wasn't getting any sound out of the old number keys. So check it. Now they're not quitting. Oh, because I commented out things in here. Yep. Ooh. Not open off. Because the key release tells it to stop. About. We're no worse off than we were before, and this is a bad sound coming up. 1, 2, 3. Okay. All right. So there's two possibilities. One is right here, where we are taking our PCM data, which is 16-bit data, and dividing by the maximum number you can have in a 16-bit number. Oh, okay. What about this then? It's signed to PCM. Yeah, so let's have that 65, 535 divided by 2. 32, 767. Let's try 32, 767. 32, 767. Now we'll get positive and negative. Maybe it's a saturation problem where everything we were doing was saturating and positive, and there was no negative values. Also a good question. What's am I casting that to? Int. All right, let's cast that to int. And int. That way we keep our signed data. Debug. I'm changing the header files. That always seems to cause my issues. So we do a full clean and build. If this works, we might be just about done with this feature as far as getting it in and working. Should be nice. How are things going in the chat? A little dead today after some excitement. Ooh, let's see here while we're waiting. I do have a Discord channel where I will send out notifications when I start a stream. What time is it? Oh gosh, 4:40. It's almost time for me to start wrapping things up here. Complete. Run it. All right. Potentially a horrible sound in 3, 2, 1. Okay, well, that's interesting. That is beep. Is that the beep? That is the beep. Interesting. But then the beep ends with a weird click. Why would that be? That's definitely the beep. What about? I'm gonna make it a click instead. But we're gonna get a double click. It seems to not be cleaning up the end of buffer very well. Possibly no, should not give trash in the end of the last frame. Or get like a double click. So yeah, feel free to hop into my Discord if you want to know when I start a stream. Let's see. Okay, so it is playing the sounds correctly. It's just not ending correctly. Let's look at what could be happening. It's playing the beep and then a click. Out, 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 out. You know what? Or just do this. For each unsigned int index frame in the frames per buffer, do this. Zeroing it. Maybe we have some trash at the end from uninitialized memory. I don't think that's it. If we pre-initialize everything to 0, that isn't really that expensive an operation. So we'll just try it. Oh. Oh. Out. Hold on real quick. Just a second. Okay, chat. I have to go pick up my son. I thought I had another hour, but I don't. So that's always exciting. Also need to give my kids instructions for dinner. Huh. Weird click at the end. The sound is right. Okay, well, I'll have to take a look at it tomorrow, but thank you for joining my chat. This is a discourager of hesitancy, writing code as minimal library dependencies as I can, no game engine. Trying to build a game, very simple one to start with. We'll get more complicated in the next one. And we will see you tomorrow. Join the Discord if you want notifications when I start streaming. And thanks for all the chat. Appreciate your attendance and your feedback. Have a good one.